All right, so the lab we're doing today, okay, is going to involve the conversion, or going to involve a mechanical energy conversion. Right? We're going to be using these ramps, okay, along with these carts that are up front here. Okay, that would be in particular these black plastic ones. Okay, not any of the others, because the black plastic ones are designed to fit in the grooves on these ramps. The other ones will just bottom out, and your experiment will not happen. So make sure you're using the black ones. Okay, and really what we're trying to do here is a couple of things. We're trying to do a little bit of stuff with conservation of energy, but we're also looking at the efficiency of a mechanical energy conversion. Right? We're going to have a ramp, and we're going to place a cart at the top of that ramp, which means it'll have what kind of energy? It'll have potential. All right. Then we're going to let it go down the ramp, and we're going to measure its kinetic energy at the bottom. And then we're going to compare the two. Okay? In the perfect physical world, those two numbers would be exactly the same. They'd be equal. Right? Obviously, this is not the perfect physical world. We're going to notice a fairly significant difference, okay, between the potential energy at the top and the kinetic energy at the bottom. The challenge is in measuring the kinetic energy at the bottom of the ramp, because we would have to know how fast the cart is going at the bottom of the ramp, and we don't have any way to measure that. So we're going to have to do a little bit of stuff with work energy theorem as well. Okay? What will happen is we will allow the cart to go off the end of the ramp and roll to a stop along the floor. Okay, what's bringing it to a stop? Friction. Okay, friction is a force, and if we measure the distance over which it stops, we will know both the force and the distance. Then we'll be able to calculate how much work friction did in stopping the cart. That will be the kinetic energy it had at the bottom of the ramp. Okay, everybody follow me there? Because friction will take all of that away as it slows to a stop. So we'll have to do, there's a few measurements we're going to have to do. Okay, they're not hard measurements, and then a few pretty simple calculations to get the data that we need. Okay, so big thing here, guys, with our lab is, okay, our problem, for some reason it's not on there. I'm not sure why. Okay, but our problem here is essentially how much energy is actually lost in a mechanical energy conversion. All right, that's what we're trying to figure out here. How efficient is a pretty basic mechanical energy conversion, right? Our design here, okay, is going to work like this. So as I was saying to you before, this experiment starts out with what kind of energy? Potential, okay? And we're comparing that to the kinetic. Those might be two important variables as one influences the other. Okay, this experiment doesn't start or doesn't happen unless we give this thing potential energy by putting it at the top. Okay, and then we're going to be comparing that to the kinetic energy at the bottom. Now, some things that need to remain the same throughout this lab in order for it to be valid would be anything that can affect that conversion of energy along the way. For example, this thing. Okay, would I want to change this at any point during the lab? Nope. Okay, what's bringing the cart down the ramp? Kind of important that that doesn't change at any point during the lab, I would think, okay, as it might affect the energies. Okay, and I'll let you guys think up a third one. That gave you 2 out of 3 there. Okay, so our materials are pretty straightforward. We got the ramp. Okay, we're going to have a dynamics cart. I'm giving you the mass, so you don't have to put it on a scale, because mass is something you need to know in order to calculate the various energies. Okay, you'll need a calculator, and you'll need to use the stopwatch on your phone, okay, in order to time this. Pretty straightforward. All right, so in the initiating and planning part here, this is kind of getting it all set up, okay? Keep in mind there's several variables you will need to record in order to calculate the energies, okay? Obviously potential energy, in order to get that, we need to know the mass of the cart. We've got that. And we need to know the initial height of the ramp. Okay, will that be fairly easy to measure? Yes, okay? Measure from the ground to the top end of the ramp, okay? That'll be what we need there. in order for to get the kinetic energy, we'll need to know the mass of the cart, the distance traveled by the cart after it leaves the ramp. After it leaves the ramp, we don't include the ramp, okay? And the final velocity, which would be 0 because it's coming to a stop, and the time of travel. Now, again, this time of travel is only after it leaves the ramp. Okay, we're not timing it on the ramp, we're only timing it after the ramp. Okay, so we need the distance and time for after the ramp. So that means you'll have to be watching it carefully if you're the timer person. As soon as the front wheels are off, start it. Okay, and then stop it when it actually comes to a stop. Okay, values that we're going to need to calculate. We'll need to know the acceleration of the cart. The formula we're going to use for that is given to us here. Okay, it's a manipulation of a formula we use in Physics 20. It isn't a formula you will ever use again in Science 10, but you'll use it all the time in Physics 20. Okay, that formula is that acceleration equals 2 times d divided by t squared. That's why we have to measure the time and the distance after the ramp. Okay? The reason we need that acceleration is that we need it to calculate the force of friction. All right? And that's what we're going to be doing here. Okay? It says here that the kinetic energy at the bottom of the ramp will be equal to the work we do against friction. We calculate that by going mass times acceleration, which gives us the force of friction, multiplied by distance. So that's our force times distance calculation right there. So we'll take the mass of the cart, we'll multiply it by the acceleration we calculate here, and then we'll multiply it by the distance traveled. Everybody all right with that? And then the potential energy, okay, in order to calculate the potential energy, we just go m times g times h. It says FD here, but obviously it's potential energy, so that's the force of gravity times distance, m times g times h. All right, so those are some of the calculations we'll have to perform. So we're going to set up the ramp, okay, and the height should be around 15 centimeters or less. Okay, like 10 is probably even better. So I've got 3 textbooks under there. They're not really thick textbooks. Okay, they're this size. Okay, I have 3 underneath there, and that cart traveled quite a ways. Okay, after the ramp. So you definitely don't want to go any higher than that. Okay, otherwise you're just going to hit the wall, and then you can't use that. This thing actually has to stop because of friction, not because it hits something. Okay, so let's say probably around 10 centimeters, 15 tops, okay, is your maximum height for your ramp. Okay, you'll place the dynamics cart, I don't know why it says rubber band here, should be at the top of the ramp, okay, and then you just let it go. Okay, this is the wrong procedure. You have the right procedure on yours, right? Double check here. Nope, yours has the wrong procedure in it too. Okay, not to worry. We'll just go over how that's going to work. You're going to put it at the top of the ramp and let it go. Okay, there's no rubber band here. We used to do this with a rubber band and we'd shoot the carts out, but they would always spin and we wouldn't get good data. This is way easier just because it rolls down the ramp and it goes pretty straight. So we're doing it that way from now on. So what you're going to do is you're going to be filling in this chart that you have here. All right. The potential energy is going to be the same every single time. So we're only going to calculate it once. Okay, it's m times g times h. We're not changing the ramp any. We're just doing 4 trials just for consistency, and then we're going to average them. Right. So the things we'll be getting from each trial: the distance traveled after the ramp, the time after the ramp, the acceleration, which we're going to calculate by going 2 times d divided by t squared. Okay, EP, which will be m times g times h, and the kinetic energy, okay, which will be our mass times acceleration times distance. Okay, that we'll be using there. So we'll be filling all that stuff in, right, as we go. Right, so you'll have your chart here, right? Like if this would be my calculation if I had a 25 centimeter high ramp, which I'm not going to have because that's way too high, right? But that's how I would calculate my potential energy. Okay, I calculate my kinetic energies by going mass times acceleration times distance. So I put those calculations in here. Okay, actually I won't even fill those in either. We're going to have those be NA as well, because we're just going to calculate this stuff using the averages. Okay, so I've got times in here, but it was for when I did this with the 25 centimeter height, so I had lots of room because I was by myself on a Sunday in the atrium. Okay, so you don't have to worry about that part. Yeah, I did. What? I have no life. Okay? So we're going to fill that stuff in, and then when we do this calculation here, this is going to be using the averages, okay? So when we go mass times acceleration times distance, we're going to use this average acceleration, okay? We're going to use the average distance here for that calculation. Everybody with me on that? Right, so we don't have to do it 5 times. We're just going to do it once, okay? These calculations, okay, so add them together, divide by 4, get that number, add them together, divide by 4, same here. All right, and then for your analysis, okay, you're going to be calculating the work done and putting the cart on the top of the ramp. Okay, that's pretty easy. So basically one of the analysis questions is filling in that chart. Okay, calculate the acceleration using your average distance and time. I want to see your calculations here. All right, so just either do them on paper and take a picture and insert it, or just do it by typing it in. Okay, it's not like they really be hard to type in. But I want to see that work. Okay, calculate the kinetic energy. Again, show your work. So first 3 questions are just calculations. They're simple calculations. I just want to see them done. Okay, for number 4, outline how you determined the potential and kinetic energies of the system. I actually just told you all of that. Okay, here's how we were going to calculate the kinetic energy. It was going to be this and this. All right, so you might want to go back and listen to this again. Okay, potential energy, how do we get that? Okay, and then for number 5, this is kind of the most important one. Did the potential energy of the system equal the system's kinetic energy? That's yes or no. Then why or why not? Okay, suggest reasons for your results. What I'm looking for here, okay, would be where did the energy go? Okay, what did it turn into? Those would be suggestions for ways to answer that question. Okay, did it turn into other forms of energy? What were those forms of energy? Okay, things like that. It's probably not a bad idea to maybe take like a video of one of your trials. Okay, just so that you can make those observations, okay, including, you know, having the sound for the video and everything. Sometimes that helps you to decide what forms of energy might have been formed there. Okay, and then same as always, conclusion, copy paste your hypothesis. Okay, explain why you can accept or reject it. Okay, evaluation. Sorry, we didn't talk about the hypothesis. We skipped right over that, didn't we? Okay, in the hypothesis. Okay, the if part needs to talk about the first law of thermodynamics. Okay, you basically need to say if, okay, energy cannot be blah, blah, blah. Okay, talk about that, talk about the law of conservation of energy. Okay. Okay, the and part will describe the experiment. Okay, in the then part, talk about what's going to happen in this energy conversion. Where's the energy going to go? What's going to happen? Okay. Okay, so the way this is going to work is we'll have 2 groups work in here, and I'll put 2 groups in the chem lab. Okay, so that you've got enough room. So one group can use this whole front area, one group can use the whole back of the room. That should give you plenty of length for the cart to come to a stop and not hit anything. Okay, going obviously between the rows, they'll hit desk legs and stuff because they don't perfectly go straight every time. Okay, so we'll do 2 in the chem lab and 2 in here. Okay, remember, all you're doing is 4 trials. What you're recording is the height of the ramp, which you only have to record once. Okay, how far the cart goes after the ramp, how long the cart rolls after the ramp. That's it. Okay, so really it's only 2 things on every trial: how far, how long. Okay, everybody with me there? So it really shouldn't take too long to get the data that we need. You'll probably want to run a few trials, you know, just to kind of make sure your cart goes and doesn't hit anything, okay, stuff like that. Another thing to make sure of is that you put the cart down the ramp the same way each time, right? It doesn't really matter which end is forward or backward. This is supposedly the front end, but it doesn't really matter as long as you do it the same each time, okay, just for consistency's sake. Make sure your cart's wheels are tight, okay? Just give the wing nuts a quick check before you send it down. If they wobble a lot, okay, and get loose, then they can break. We have a lot of these broken now, so just make sure the wing nuts are tight. Okay. Any questions on what you're doing? Okay, so grab a cart and a ramp. and then you can use whatever you want to make the height of the ramp, a couple of binders, okay, or whatever, okay, and you guys can get started. I'll unlock the chem lab for those two groups.